Welcome to Scroll's workshop. I'm Vincent from Scroll Develop team, and today's topic is going to cover L1SLOAD, which is a super powerful precompile that allows to direct read L1 data from your L2 contract. And you can integrate this powerful feature into L2 apps and make some very creative features, playful features in your project. And today's we will split our content into 4 different parts. I will go through first 2 really quick because we have limited time of 30 minutes. And I want to reserve as many time as in our demo part. I will show you some code example about how you use L1SLOAD. So first, let's discuss the idea behind L1SLOAD. It is called L1SLOAD, so you have to have some basic knowledge about L1 and Layer 2. I will go this really quick because I guess you are the professional hackers. You know some basic information about it. So in order to solve a blockchain trilemma, which we are known, it is almost very high security, very high decentralized level, and super scalable for every blockchain. Especially we know Bitcoin and Ethereum has facing those problems. They are very secure, they are very decentralized, but they ability. So in order to solve this, we have built up Layer 2, so-called rollups. There's 2 achievements to build up rollups. One is using fraud proofs, also known as optimistic rollups. Another one is using ZK proof, which means it's using mathematical equation to guarantee that your input is definitely correct. So Scroll is a ZK EVM Layer 2 based on Ethereum ecosystem, so we can characterize Scroll as ZK rollups. Instead of the optimistic rollups, they're using fraud proof and have longer exit window because they have to pass the challenge time. Usually it takes 7 days. But when you use ZK proof, it can be verified very fast. Like Scroll has a very fast finality time. For example, if you withdraw your assets from Scroll to Ethereum Layer 1, it's only take you less than 40 minutes. And I think it's the fastest among all of the ZK rollups for now. And this is the typical structures which the ZK rollup looks like. You have a sequencer. It's a duty for sequencers to produce blocks, arrange the transactions order, and then you before you submit back to Layer 1 to do some verification, you will have your prover to generate ZK proofs for your blocks, and there's a special aggregator which can aggregate many blocks together so that you only submit once, but you can prove many blocks. For example, for now, Scroll, maybe one bundle of Scroll ZK proof can prove over 10 blocks for now. And you will pass your ZK proof to a smart contract as a verifier, which deploy on Ethereum. If it passed, it can mathematically prove that all of your transactions within the blocks are correct. So people's transactions are correct, then you can release your assets from Layer 2 to Layer 1. It's a very fast process. But there's still many reasons to use L1's data directly from L2. Why? Because there's few advantages. First, it's the data stored on Layer 1, especially on the Ethereum, is super secure, and it's also decentralized guarantees. And also, the data on the Layer 1 is also acceptable for all of the other blockchains or Layer 2s. So once you accessing data on Layer 1, you can also reflecting your changes on different Layer 2 which can access the data. So that's why we come up with this idea of L1SLOAD precompile. Because there's so many Layer 2s right now. If a user want to manage account states, the most efficient way, I think, is they both reading the data from Layer 1 instead of on different Layer 2, and they have to communicate with each other. Let's give you only need to make your change once. All the other Layer 2 can reflect in the changes and make some very fun functionality. For example, if I holding a special token on Layer 1, and if I gain more tokens on different Layer 2, if they can read my balance on Layer 1, and they can do a corresponding action. For example, if I accumulate my token over 1,000, I can get some free NFT mint. But if you read data from another Layer 2, it is quite hard for people to maintain their own states on different Layer 2. So we finish this part, and I will introduce you about what is L1SLOAD. So L1SLOAD is a precompile that I just explained before, we want to enable user to directly read L1 data through a integrate with L1 L2 dApps. It is currently now our RIP instead of our EIP is still in proposal stage, but it's proposed by one of our co-founder and our CTO, Hai Chen. You can check the details of this proposal under RIP 7728. And if you think it's very useful, you can vote for it. And we hope we can pass this to become a real EIP in a very short amount of time. This is basically the idea. For example, we have some key information stored on layer 1, which is so-called Ethereum, and we have two different layer 2 can both access that layer 1. So, for example, if I store my key A on layer 1 and both scroll and OP can read that key, and if I replace my key A to key B, we do the scroll and OP network can automatically reflecting this change without asking again. Because now they're accessing key B now. Let's go through some implementation details about L1SLOAD. You don't need to worry about too much. I just want to emphasize the actual implementation, which is under this part. It's explain you how L1SLOAD actually works. So when the L2 node encounters a call of the L1SLOAD precompile, it will go verify if the input is well-formed. If this well-formed, it go actually to call Ethereum or layer 1 block RPC query to this one, is get storage at address. So basically it will fetch the data from the L1 node, and then it will give you output buffer to your to which the smart contract or user called L1SLOAD precompile. We want to also examine the how the input and how the output looks like, and how the gas fee you cost. Basically, right now the standard is it have the fixed gas cost 2,000 for each of the extra slots that you want to read. If you're adding more 2,000 to your call, and right now the maximum call slots per time is 5. It does not mean from 0 to 5 slots. You can choose whichever slot that you like, but the maximum number of slots you can retrieve one time is 5. And the output or the return type, it looks like this. It will divide it by slot and ordered one by one with your order of keys. And each of the return slots data contains 32 bytes of data. And this is a very simple usage. You try to integrate your L1SLOAD into your smart contract. You can just basically first you need to load the address of L1SLOAD because it's a precompile. The contract address is fixed. I will give you the contract address later. But when you want to use it, you just call the address static call, encode with your layer 1 contract address and your key. Keys also means slot number. If you know your slot number, you can access whatever data that you stored on layer 1. I will give you code example during our demo time. And before you actually can use it, you need to get some testnet token because L1SLOAD is not available on Scroll Sepolia. Currently, we have created a separate testnet for it. It's called Scroll L1SLOAD DevNet, and we have special faucet for it. It is Telegram bot. If you want to gain some token, you can scan this QR code and get access to this bot Telegram group. It's very easy. You just simply type /job with your destinate address, then you can receive 0.1 testnet token on it. And we also create many useful reference and guides for using L1SLOAD. This is a very typical one, and I think it's very useful. You can scan a QR code provide to you, and this is all the network setting that you needed to connect with Scroll DevNet, which L1SLOAD is available. I will pause there for a few seconds for you to scan the code. And I think everything's ready. Now we can start our journey with L1SLOAD. this is a Telegram group, faucet Telegram group that I just mentioned. Here is just some use case. You /job with your account address, and then you can get one 0.1 test token for free. And I will leave it here, probably drag it back to my main window, and I will drag the my code example here. Well, it's to operating in different window. It's really challengeable, but I hope I'm doing it. Okay, cool. So I'm using Remix. It's a well-known web coding explorer, and it's very easy for everyone to use it and debugging your smart contract. I have provided 2 smart contracts for you. One is called Let's Scroll token contract, which I'm gonna put this contract on the layer 1. In this case, it will be on Ethereum's testnet, Sepolia. And then I will use my L2 consumer contract to retrieve our storage data on the Let's Scroll token. What am I gonna do? I'm gonna try to retrieve the balance of it and retrieve the name and the token symbol on it, and then to give idea about how L1SLOAD looks like. Let's first examine this token contract in details. So this L1 token, it's ERC20. I have using the libraries from OpenZeppelin ERC20. I will explain to you why I want to use it, because I want you to be aware of some small things. Because if you forget to understand the slot arrangement, then you may encounter into some trouble when you're trying to load your slot. And then I provide few variables here. We're trying to retrieve them later, okay? But let's see what this contract looks like. It's very simple. When you deploy it, it will mint 1 million of LTS token to the message sender account, which gonna be my account. And let's examine L2 consumer also. It is an actual code example to using L1SLOAD. So for let's skip this blocks L1 blocks address first, because this is another precompile. We're probably gonna cover it in the different workshop or online video. You can find another details about it. It's also a powerful precompile. It provides you L1 block states on layer 2. But we will focus on layer 2 SLOAD or L1SLOAD precompile for now. This is the address of the L1SLOAD precompile deployed on Scroll DevNet. Like I said, it is a fixed number, so you can just import it. And this is a customized byte32 to string function. You can borrow the code directly. And this code example is also live in our guides. So if you go back to scan our QR code, you will find this code base. You can just copy paste if you want to read some, if you want to convert your byte32 to strings. I will not cover these details because this code example, you can easily generate it from ChatGPT if you like to use. Now here is an important part, retrieve all. This is a function that I write by myself. It takes the L1 contract address, also take my account address as input. It will return 5 things. Remember, when you call L1SLOAD, it's maximum give you 5 slots per call. So I want to retrieve all five data from my L1 account, and I need to I need to calculate the slot number first. In fact, it is very simple because it's all the slot number actually is arranged by orders. So it's starting from 0 to 1, 2, 3, 4 because I have 5 different variables I want to retrieve. Instead of 0, why I put this as account balance stops? Because if you recall the ERC20, let's go back to our Let's Scroll token. That's why I use ERC20, because I want you to be aware our slot 1 is not this owner. It's actually the variables in this variable in this smart contract ERC20, because we import OpenZeppelin ERC20 into our account into our smart contract. So actually the slot 0 is this one. The slot 1 is this one. The slot 2 is this one. The slot 3 is this one. The slot 4 is this one. Instead of our owner and receiver. You will see it later. And also, for slot 0, it's a mapping structure. It's mapping the address to some number. So it's not 0 because when Solidity compiler compile your mapping structure, it will using a very specific algorithm to counting the actual slots, which I provided here. First of all, you have your base slot is 0, like I explained. This mapping is placed on the slot 0, and then you have to finding out the actual slot number mapping with your account address. So we'll first do check with your account address with slot number, which is 0. You do this quick hash function, and then you get your really account balance slots. So it's whatever it is. So I put it on a 0, and then we have 1, 2, 3, 4. It's just follow the orders, and you can get all of the data. And then when you get back the data, remember the data is raw data. You need to do some you need to do some conversion. I was using the assembly code to do the conversion because the first 3 are the unit 250 u integer 256. So basically, you don't need to do a extra conversion. You just read it. But for the last 2, it's token name and token symbol. It's string. So it is time when we bring back our byte32 to string function. You remember that conversion function that I explained at the very beginning? I want to convert my byte32 to string. So I use it, and then I get the data back. Okay. And this is for later. This is just retrieve 1. It's only retrieve 1 slot number. Whatever the slot number you put, it gives you the result. I will use this for another example. So let's first try to retrieve all and see what is going to happen. So I have deployed the Let's Scroll token on the Sepolia, I guess, 20 minutes ago. This is the contract address. Yeah, it's like 12 minutes ago. I would like to copy. Is this copy? Yeah, copy the address first, and then go back to Remix. I want to deploy my L2 consumer, and then so that I can retrieve data on layer 1. So let's do compile. Compile layer 2 consumer. Cool. And then I go to deployment. Be sure that you are on the correct network. Currently, it's on Sepolia because the network IT isn't a Scroll DevNet. When you successfully setting up your network, you will be able to switching it through your MetaMask. I will try to find. Yeah, I call my customer network Scroll DevNet. You can also call it L1SLOAD. It doesn't matter. Let's check the chain ID again. Now it's correct. So I will deploy it. To deploy it, because I made my L2 consumer ownable, it's not mandatory. It's just my preference because I do not want to clear deploy accidentally. So whenever I want to click deploy, it requires me to put my owner as an input. So I will put myself as owner, and I click deploy, and I will click confirm. Now we have deployed our L2 consumer, and let's use it to retrieve data on layer 1. That's one thing I really like Remix because after you deploy it, provides you the real smart contract interface to you that you can directly interact with. So now let's go to retrieve. Let's do retrieve all to check if the data is correct. So just wanting you to recall what we have done before. So we deploy our layer 1, our Let's Scroll token. It will have 1 million LTS to the minter, okay, to a contract creator. So go back to our layer 1 contract address and put it as an input. And because myself is only owner of this token, so I will put myself as account to it. I will copy my account address and put into this input. I'll just call it. And now you can see the output. I'm not so sure if you can see it clearly. Maybe I zoom it up, zoom in a little bit. Now, so first, just recall to ERC20s, like those variable. First is the balance of your account. The second is allowance, because currently I do not give any allowance piece outside, so it's 0. And second is the third is total supply of your token. It's 1 million, because it has 18 digits, so it looks so long. And then we successfully retrieved the token symbol, let's scroll, and the token name, let's scroll, and token symbol LTS. This is so powerful because it shows you, because currently I'm on Scroll DevNet. You see the chain ID? It's not on Sepolia, but actually I retrieve data from Sepolia. This token is deployed on Sepolia. So that's the user case. Now I want to do some fun things. I want to switch back to Sepolia and then transfer 1,000 LTS to another address. And let's see if the balance of this can be actually changed. First, I want to import that tokens. Yeah, let's go back to our smart contract. I copy the address, and I import the token. Now you see it's LTS, right? And has 18 digits. Let's see how many I have. Looks like currently I have 1 million. Yes, it's 1 million LTS that I have hold. Now I want to transfer this to the others. I will just send. I randomly choose the account. Maybe I will send 1,000. Let's click the continue. Submit. Wait until it's finished. At the meantime, I want to go back to, yeah, it's finished. I want to switch my network back to Scroll DevNet. So now I'm on the different network. Let's see if I can retrieve the changes, if the change is successfully reflecting on layer 2 by using our layer 1SLOAD contract. But first, because I switched my network, my previous interface has gone. I need to get it back, but it's very easy. If you click add address with your previous deployed smart contract, you can retrieve it back. So because our Scroll DevNet does not support Etherscan, so you have to use our own block scout built by it. Okay, that is also provided in our L1SLOAD guide. You can find everything you need under this guide, including the block explorer. I have shared this QR code before, so it should be easy to find it. Let's see. This is one of our. This is my account address, and let's check this contract creation. This one should be the one that I just created for reading L1 consumer. Just in case, I want to refresh it to get the latest one. Okay. Click the transaction. Let's find the contract address. I think this one is the one that we need. So let's retrieve this interface back again. let's see if it's, let's check the owner. I'm just assuming this is the correct one because my eyes cannot read it clearly. But let's try retrieve it. Let's see if it works. Looks like this is not our contract address. Let me Oh yeah, because this is not at our Scroll DevNet. Just be sure this is a common mistake that people would have. You forget change your network. So let's go back to the actual network. Now it's back to Scroll DevNet instead of Sepolia. Now let's retrieve this again. Now you can see the owner is myself, so I think this one is correct. And let's retrieve all. See the balance of it is actually changed. It's not 1 million again. You can read it. So that's how powerful the L1SLOAD is. And based on that, you can do a lot of very cool features. You see, for example, if you holding that amount of token on layer 1, then you can have a free mint of NFT. So you can based on that, you can do a lot of creativity things. And I want to really quickly go back to my slides and give you some information about our bounty. So yeah, let's give all of things out because our time runs out. So in ETHGlobal, we have provided 2 bounties related to L1SLOAD. First is best innovation on Scroll. It provides maximum 10K USD as an entire prize pool. If you have deployed your smart contract which integrate with L1SLOAD and deploy on Scroll DevNet, you will have a chance to win that bounty. And another one, we have a specific track only for L1SLOAD. It's a best use case for L1SLOAD. It's no matter what type of dApp you have integrated with L1SLOAD, just deploy and try to show us the evidence that you actually integrate with L1SLOAD and reading some L1 data through it, then you will also have a chance to win it. And you can, if you do that, you can both apply for these 2 tracks to increase the chance that you win prize, okay? And I will because the time is up, so I need to end up this. Thank you very much.